Yes, it's good to go.
Okay, thank you. First, I would like to thank you for Kola Waller and also Wolfram Schmidt for inviting me to join this virtual conference. I've been enjoying my whole day so far. It's a great weekend for me, certainly, no doubt. And now I'm gonna start. My name is Ruoyu, and I now work as associate professor from London South Bank University. My topic today is based on my recent years research, study, and practice, think about how I link the digital technologies, including but not limited to, let's say, BIM or building information modeling, into the circular practices, like how we reuse and recycle or whatever other ways of circular use from the construction and demolition wastes. Basically, what I will do is I just will go through the three papers that I published from my prior studies in the past few years. Basically, the three. So I will go through from the first until the third. Then my presentation will be over. So first, I will start with that an empirical study because I'm not just doing the computer work or the modeling with the information technologies, but actually I used to work also a lot on the site, visiting the site. I crush concrete, like I said, using the recycled aggregate materials. So let me start with the first paper. So I just go through the empirical study that I did before a few years ago in China. It's another developing country. And utilizing quite a variety of different reference sources, secondary materials. So I made a table of comparing these major developing countries like Japan, the US, Australia, and China. And if we see that the annual generation of the construction and the demolition wastes, okay, construction and the demolition, that's because China has a large population. But if we think about the generation of the waste from construction and demolition per unit land, per square meter, well, sounds like Japan's even higher. Well, if we think about the average waste per capita, per person daily, that sounds not significant differences, except this metropolitan city, Shanghai. Well, let's see about the average tipping fee in the US dollar per town. That somehow you can tell the correlational relationship. Like if the policy charges more tipping fee for downcycling or for dumping the wastes, then you can see the recovery could be higher. So somehow it shows the policy could play an impact on the practice of the construction and demolition. Well, I think it will be also be interesting to see if we have the data from Africa or from several African countries or the regions to allow this kind of cross-country comparison. Okay, let's move forward. So that's what I used to visit a lot. Some of the factories in the mainland of China. Basically, we know when the contractors or the demolition companies, they need to get rid of all the construction and demolition wastes from the demolition or from any new construction projects. So they have to pay the fee, or they have to drive quite long, maybe 50 kilometers or even longer, to the rural area in order to find the land filling space if they are not illegally dumping them. Well, there are some brick or the construction building manufacturers. They could actually take all the wastes. So they charge, from one hand, these companies, manufacturers charge from the demolition of the contractors. On the other hand, they use the waste to crush into debris, into fine aggregates, and then they make the reused or recycled products like the bricks, coming from pretty much all from the wastes in red color bricks or the concrete. So that's basically the workflow from the debris into the reused products in bricks or some other hollow bricks, as you can see. They provide the land, crush, and into the factories, and they make a variety of different bricks. Can be hollow bricks for the solid bricks. Okay, so that's quickly for this first study. So what I found out from the visits or the talking to the different stakeholders, what my findings from that study is, in some developing economies, like the governmental policies, guidelines, which I believe we have been talking a lot today, were perceived as maybe the initiator or the driving factor to start implement or to start to grow the culture of circularity in practice, in the professions. However, if we look at some countries like Japan, they are able to have their own market. It's really, if I call it a top-down approach, started from the policies or guidelines, then I could call some other nearby countries like Japan, they would be more market-driven. I could call it bottom-up. So because the companies are able to maintain and have their sustainable business to recycle, reuse, or whatever circular use of the construction and demolition waste, even without any governmental financial incentives. So I believe that what it should, in the longer term, what ultimately it should look like is they have their own industry of utilizing the wastes, because we believe the wastes are not really wastes. They are also resources that might have been put in the wrong place. But if put in the right place, they are the resources to be reused. Okay, so some other key factors as a conclusion of that study is are the key issues identified in impacting the construction and the demolition waste. Quite some other factors, not only from the technological standpoint, but also we know it's really also a human factors, policies, like the client's demands on the waste treatment, whether the project client is asking the circular use of the waste, which would be generated during the construction or during the demolition, and also the standards. And the other thing I feel quite critical is it's very time consuming or the labor intensive if we want to sort out the waste from the beginning. It's very difficult to categorize, separate in like concrete, brick, earth, or whatever the waste types, and how we classify. And in generally, as you can see from the photos, it's just everything together, all the different things together into the waste and landfill or downcycled. And also the multi-party communication of the multiple stakeholders, especially in the early project stages. The earlier, the more effective that waste sorting strategies could play. Okay, let's quickly now move to the second study. That's another more recent paper. It's basically a review of all existing studies. I reviewed all hundreds, quite many hundreds of papers, published papers in the scholarly research. What I used is what I call the text mining data analytics to analyze all the keywords from Scopus, which is a database of the scientific published studies. From the keywords, I can categorize what I believe it is less subjective, more objective approach to categorize all these existing studies. Basically, I reviewed all the studies, including both the technological, material science, and also management policy-based studies. So let's see. Basically, the color are automatically generated by the text mining software. So if we start looking at the first theme is waste treatment methods in the blue color. So quite a lot of existing studies have been focusing on the reuse or the recycling or other circular use according to the circular economy hierarchies. Some are talking about the sustainability impact. You can tell from the size of the font. We talk a lot about the carbon footprint, carbon emissions, or the PM 2.5 or whatever other pollutant, air pollutant. These are considered the impact. The third theme is waste materials and the technical studies. Waste materials, for example, we know concrete is the most widely consumed worldwide materials. So there have been a lot of studies on the quality or the properties or the durability of concrete, adopting recycled wastes, recycled aggregate, and how would that affect the mechanical or the durability and other properties of concrete. Quantification of waste generation. So quite a lot of studies talking about how we estimate the waste generated. Typically, we use a weight per ton, right? A weight in tons. So the data source or the data quality, how is that the data quality, how that could inform the policies that our previous colleagues have just talked about. And also the emerging technologies, which I am going to cover later on for today, emerging technologies. So we can see it's not only about the building information modeling, but also other emerging digital technologies like data analytics, GIS, which is Geographic Information System, and a variety of other digital, which they could be integrated to form a system to allow a more holistic decision-making, and how the digital technologies could assist in the traditional construction and demolition waste management. Lastly, we can see the red color. It is about some other developing economies or the prefabrication strategy, which I believe one of our colleagues in today's conference has also mentioned the modern method of construction. So how the modern method of construction or the prefabricated approach could also reduce and help with the construction and the demolition waste. So according to this visualized map of the keywords from many hundreds of studies, which are summarized. So that is a framework which I summarized according to the according to a large sample of the published studies. So if we start from the middle, the yellow color, research themes. So according to the themes, I would summarize them, categorize them into these different themes, follow up with the prior text mining-based visualization. On the left side is what have been done from existing studies. And the right side is what I think could be further down as the research directions. So they are linked by the themes in the middle. So for example, let's see, waste generation. So there have been quite some studies talking about how we quantify, how we estimate the waste generation rate. So for example, 10% of concrete will be wasted, or you can estimate every time we produce 3 houses, 2 houses are wasted. So that's just an example of the waste generation rate. And the modeling, simulation, or validation. So what we can do in the near future, what I believe is benchmarking. So can we have a benchmarked data, to inform the policy, and the design and planning and waste generation. And actually what I now believe is we have focused a lot on the weight of the wastes. Are there some other measurements? For example, the potential of the circularity level, or the reusability or recyclability, or remanufacturability, or this kind of different measurement to evaluate the attributes of the waste according to the category. That's something I'm thinking about now. I have not been doing anything yet. And second theme is construction and the demolition waste treatment method. As we all know, the recovery or prevention, or there are multiple R starting strategies to handle the waste. So here are some ongoing directions that I am thinking of. For example, the LC life cycle assessment in both the project level, the building material level, or also the component level. If you think about the modern method of construction, it's a modular component. And products containing the recycled contents. So some of the experts today included also have been done a lot. I believe the recycled aggregate, which are used to produce the concrete, or the supplementary different types of ashes to produce new concrete and the waste sources. So that is what I'm thinking of for the future directions. And the next theme is management practice. So we talk about the policy guidelines. I believe we all have mentioned that in the earlier discussion today. So the direction could be, I believe, developing the effective construction and the demolition waste program and evaluate the effectiveness of the program. Further, since I said there are quite some human factors, and some of the comments I can see today is about the mindset of people or the local stakeholders using the waste. So I believe sometimes human beings are more complicated than their technology. Technology might not be the main issue. It's mainly about how human beings understand and interpret the technology. So there are a lot of human factors issues, or the reluctance to change to the new circularity, or the mindset staying in the more traditional way of downcycling, or just simply dumping the wastes. So how we create the culture, what I call the culture in the circularity culture, and how the existing programs or the policy could inform to nurture the culture. The last theme is about the emerging technologies or concepts, like the BEAM, like the big data analytics, and how we, and also what we call the digital circular economy. So how we utilize a more reliable data source to drive the digital circular economy. That's just a quick summary of the second paper. Now let me move to the third, which is more recent, what I call the methodological framework for the deconstruction management. So we know a lot of us and a lot of studies or practice have been more focusing on the construction management, but I would like to focus more on the deconstruction. Why I think the deconstruction is also important apart from the new construction. And we know the circular economy, like one of our colleagues mentioned, the cradle to gate or cradle to grave. That is a typical life cycle assessment. When the material reach the end of life use, so how they are going back to be, how we determine their determine where they will go. So so existing studies, like I said, we have focused a lot on the new construction. What about the material at its end of service life? And also we talk about the data and also the source of the materials. One major barrier in reusing or to enable the circular reuse of the materials from demolished buildings, from the waste, is we are not sure about their source. We are not able to track. So how can we use the digital technologies to track where the material comes from? So you may have seen some existing studies. If I call the raw material, it comes from the parent material, then the current material will be the children. So you can tell somehow does the children material inherit something from their parents. So that's how we track the source of the material at its end of service life. So you may have heard about the design for deconstruction. So that is a mindset to think about at the beginning of the design. You will think about how at the end of the service life, at the design or the planning stage. So how would you include some of the environmental friendly or low carbon emission or low embodied energy raw material? Like some of the figures you have shown, the Earth is more, the Earth could be more environmentally friendly, right? It includes lower embodied carbon. However, what I argue here is actually that may apply for the existing, may apply for the new buildings. But think about how many buildings we have here in the UK or all over the world. They were designed and built without any record, without any drawing, or we simply lost their record. We lost the idea of these buildings. So how we track the source, that's the thing. So that may apply better for the new building or new projects, but not for the existing. But I think not only the developed countries, but some of the developing economies, which is about to graduate, I believe, from the developing country list, they are also slowly switching from new construction to more maintenance, operation, or renovation, or refurbishment of these buildings. So we do need to track the source or the record of the building when it was initially built or initially designed. So we need to find, in this perspective, we could see the digital tracking technologies could have some application in applying for the deconstruction or for the existing asset management. So let me move.
Dr. Jin, can you please round up?
I'm sorry, what did you say?
Yes, I'm talking about the time. Maybe we try to round up because a lot of questions here.
Okay.
I'm saying about time.
Okay, I'll be quick. So okay, just a quick review of some of the existing studies, mainly applying the beam, but I can see it's mainly for the new building or in the early design stages. So what I believe is the deconstruction is different from the demolition. The demolition is just the baseline to simply push down the building, but it's not really, may not be the best approach. Deconstruction could be the partial demolition or a small or a partial replacement. So that somehow allow us to compare the different scenarios. And so I'll now just quickly move to what I believe are the future research trends. So that's what I believe. If I'm thinking about that digital prototype, according to the limitations of the existing studies, like the data source, like lack of the data to categorize the different types of the wastes, and especially for the old buildings, we don't have any drawing, we don't have any digital models, we don't have the paper drawing anymore of the building. So how we are still able to capture these buildings to allow us to more efficiently to make the decision to decide where this material should go to, or after we decide the weight of the building if we consider it's a micro level of the buildings. So that's how somehow the digital technologies you can take a photo from the site, allowing the image processing. You can have the laser scanner to register the point cloud or existing paper drawings. Then we have the existing technologies like we know that the deep learning is actually part of the machine learning or the artificial intelligence or the computer vision or the image processing. And the captured point clouds can allow us to rebuild the model. So that's what we call the digital twin. There is a physical asset there, but there's also a digital model. So it's a twin. That's what we call the digital twin, right? And you can pre-set up the criteria that you want. You can build in the algorithm of the rules for circularity evaluation, or you can define what is a circularity. You can define the potential for circularity according to the types, according to the weight, and also to allow you to decide, are you going to downcycle it? Are you going to recycle it? Are you going to reuse it? If you reuse it, where you are going to reuse it for? So that basically describes a workflow in the algorithm. And further, I call it a holistic system into the end user layer that would allow the non-experts to also quickly decide their own properties, how many weights or how many different types of materials and the weight of each type of materials in a virtual immersive approach to allow the end user to use to analyze their own existing assets. So that's what I call the methodological framework. So the areas for the continuous work in the near future, it could be, for example, I know our colleagues mentioned the cradle to gate or cradle to grave. But what I'm thinking here is I'm thinking about from the grave back to the cradle, if we think about the deconstruction. So the end of service life. So how we make the optimal decision to make the grave material back to the cradle, so they have the next generation of the service life. So that would ask us to track the source of the materials, where it come from. Okay, and I think I'm running out of time now. Am I running out of time?
Kindly conclude. Thank you.
Okay, these are some future work just for your information.
Okay, thank you.
Yeah, deconstruction.
Go ahead.
Okay, so also to improve the whole system, it's not only about the beam, but it's really a whole digital system. If we think about the Industry 4.0 resolution, it's not only about 3D printing, or it's not only about the beam, but how we make the system talk to each other. Because I make analogies of the different software or the hardware. A lot of issues happen, like people blame the beam. One main problem is interoperability, because the data, when the data is transferred from the architect to the structural engineer and to the contractor and to the asset manager, what you understand the data may be understood differently by another stakeholder. Why that miscommunication happen? Why there is a fragmentation between the different stakeholders? Some of the problem is called the interoperability. The software or the hardware cannot understand each other. So if I make the analogy, in order for the data to be shared, we need to share the norms or the standards. And also for us to communicate, we are speaking the English right now. If I speak another language, you will not understand me. Similarly, if the software is using one standard, different standard with another software standard, the hardware or software cannot communicate with each other. So there is a need for a shared norm. That's like the language. Human beings speak language for each other to understand, even we are from different cultural backgrounds. But same thing, the software, the stakeholders, they need to have their shared norms. That is a language in this profession. I guess I will stop from here. And thank you very much. I also list my email, and I'm more than happy to pick up questions or for the follow-up communication. And I'm also keen to build any collaborative research relationship with our colleagues from Africa and from other continents. By the way, we have the UK-based funding schemes like the Royal Society or Global Challenge Research Fund. It comes out every year, so I'm very keen to build some networking activities with you.
Thank you so much, Dr. Roy Jean. That was a beautiful one. Yes, unfortunately, we are a bit out of time. I will quickly take one question for you. Yes, this question, yes, we apply the deconstruction philosophy to address the consensus. More so, no. Yes, the question that is coming from here is one problem is environmental assessment is that each model has a lot of competitors, each of which is claiming to be the only truth. At the same time, you will never find the truth. Are there any activities on a global scale to find consensus? Have you seen that question?
Okay, I'm trying to find this question. Let me see.
Yes, if the question is just about conflict between one model or the other, is there any global consensus on the way to really achieve a common model?
Yes, if I use that beam, for example, like the Autodesk company from the United States, they developed the industry foundation class that is shared standard that different software can talk to each other, like I said. And of course, we are still trying the best to achieve the interoperable. So that's it called the interoperability between the different models. And behind that are the language that should be understood by the different models or different software tools. So it's really quite a big research area. So people, how they apply these digital technologies or computer programming to make these models interoperable and to minimize information loss. So in this way, when the data is transferred or the information is shared between one stakeholder to another, we need to make sure there is no misinterpretation, or we make sure the data is not lost. So I would say it's not completed yet. It's ongoing work all over the world.
So thank you so much. I would like to thank every speaker in this session for having a